This is Chapter 10, Section 2. We're going to talk about several of the protocols, more common ones that you use pretty much every day. Let's take a look at the first one, HTTP. What's that for? Your web, right? Yeah. HTTP is the protocol, so it tells you right here the protocol is right there. The server name is www.cisco.com. That's the name of the device. And this right here is the specific file that you're asking for, index.html. Type it in. As a request, you get all this extra package of information back. And it puts it all together into a nice little presentation form that you use for web pages. Cool, huh? Wow. How does this work? It puts out a get command, it gets information on this, then it sends out the post and puts, so it posts and puts out the information you need. It's the name of the process, or the message types, I should say. There you go, message types. This whole thing here all together is called a URL, or Uniform Resource Locator. Now you know what URL stands for. Yay! Now we're talking about HTTP. If you look up there, you're often going to see HTTPS. I bet you if you look up there right now, you'll see HTTPS. Oops, excuse me. There we go. HTTPS on your PC. Again, on the back, not on here. Well, HTTPS is secure. It uses something called Secure Socket Layer. This allows encryption. Not quite guarantees, but it makes it very hard to change, and it also allows you to know that you're getting it from where they say you're getting it from. Very important nowadays because everybody's trying to hack everybody else. So, emails. I'm going to talk about that part. Let's talk about emails. How do emails work? Well, when you send an email out, you're sending your email to a server. Your server, right there, ISPA. Say if you're using the school's K-12 account, and you're sending it to a Microsoft server, we'll send it to the server of the person you're sending it to. We'll then send it down to the recipient. It's not going from you to them. There's a server in between. Some of your messaging services don't use servers. Some do, some don't. Depends if they're point-to-point or their client server. We talked about this with the last section, right? The protocols they use are SMTP, POP, or IMAP. Do not use POP3. I'll just learn in a little bit why. SMT operations. You run the protocol. It sends down there. Okay, is it on my list? No, I sent it off. POP is much the same way, but instead of POP sending a copy down, because with SMTP and IMAP, you have a copy of the email on the server still, or at least on your server. With POP, it sends the whole thing down. It doesn't make a copy that's synced up. It sends the whole thing. So if you send it out to your phone, you can't get it on your computer or your laptop. If you get it on your laptop, you can't get it on your phone or your tablet or your computer. You getting the problem here? And that's why we don't use POP. We use IMAP and SMTP. They each have their own ups and downs. Don't worry about them too much. Just know that they're much better than POP. POP's horrible. Packet tracer to try this out, see how it works. You'll be configuring some HTTPS and email services using the packet tracer. Now, these are things that you end up doing. I've done a lot of email stuff. Not much on HTTP, but a lot of email stuff over the years. DNS, or Domain Name Service. DNS is why you put in Cisco.com rather than a wonderful IP address. This is not it. Not theirs, but you might be putting an IP address in. So what it does is you send a query, who has this name, to a DNS server who has a list of names to IP addresses. So, okay, send it back. Hey, this so-and-so has this. Well, then they send this to this. Yeah, it adds another step. Because the client goes, what has Cisco.com? They send it out to a DNS server who finds out or has it, sends it back, and then once they get the IP address, then they send it out to that IP address. Ooh, it adds another step. But we need it because, frankly, people don't memorize numbers very well. That's really it. It's really it. Then you get very detailed about, / whatever file type you are on you're asking for. And how DNS is formatted? Well, there's four main types. IP address for an end device is an A record. For an email server is an MX record. For authoritative name server, which is basically a high-level server, it holds all these lists. It's an NS. And the quad A is an IPS version 6. The triple A is for IP version 4, something special. I forget what it is. Should not have told you because I completely forgot what it was for. Let's look it up now. Great. It's been too long. DNS hierarchy. Okay, so these are top level. The .com, the .org, the .au, the .co, .nd, .us, whatever else. All that stuff is a root server or top level domains with server. Basically, these are ginormous servers that hold a whole lot of records. That if your local one doesn't have to, it sends up to this guy. He knows where to go to if he doesn't know the name. And there's even higher ones, these root ones, which are core. If you don't have these, we really don't have internet. Well, we do, but it gets really, really painful. So as you go up the list, you have a hierarchy of DNS servers. So your local one, Cisco.com, will have everything for Cisco, mail, some local stuff. .com will have everything for .com. .org will have everything for .org. In theory, it doesn't necessarily work out that way, and there's what that they're beyond ginormous. And this lookup command is where you can use if you want to know the IP address for Cisco.com. There you go. Server name right there. And the secondary server name right there and the secondary address. Hey, you can use an IP address too, and it'll kick back server name. It's kind of nice, especially on smaller networks. DHCP. DHCP is why you don't have to put your IP addresses in. It's a server that we talked about on chapter 6 and 7 that will hold a list that will automatically assign an IP address within a certain range to any devices connected to their network. So they'll have one, your home router will have one, your business will have one, and they talk in between each, they use these to have IP addresses to talk to each other. These are for within your network. This is why you never have to worry about that, or at least most of the time you don't. But as an IT professional, you will be doing this all the time. At least be well aware of it. How does it work? Your device gets on the network. It turns on or directly connects for the first time. It says, hey, where's the DHCP server? DHCP server, I'm here. Want an IP address? DHCP, the new client says, yeah, I would like to request one. Then he sends it off. You can only have one DHCP server per network. You can put in two. I should take that. You can put in two, but it's not fun. Not necessarily not fun. It just can be kind of a mess. So typically only have one, even in big ones. You might have another one that's ready to go. In a moment's notice, to pop up online. They're not hard to set up if you know what you're doing. They're actually pretty easy if you know what you're doing. Surprisingly easy if you know what you're doing, actually. When I first set up my first one, I was sweating bullets because I thought it was going to be really hard, and it turns out it was actually really simple. I kept looking for something I missed when I really hadn't missed anything. So, yeah, like I said, it's surprisingly simple-ish, roughly speaking, to do. Well, here's activity to verify and configure SAC and DHCP addressing. Oh, this might be a little more fun, or might be painful. I say it's relatively easy. Then again, I have more years of experience than you do. You might want to give this a try. It should be fun. If not, whatever. It's up to you. Again, observing it. It's a lab. File transfer protocols. Okay, next protocol. File transfer protocol is how you get your data off the internet. You download a file. You download a video. It's probably going to be through an FTP. Now, by FTP has two ports. Port 21, the first port, port 21, establishes the connection and does all the controls. Basically, we got it, how much do we have, we got a good connection, no, we didn't get this, blah, blah, blah. And then there's the data one, which actually sends the data over it. There's no interruption for the data stream, in theory. You can either pull or push, which means you can either request it and pull it down, or you can push it out to a device. So you go, hey, you're going to get some data. Take it. SMB is something used typically within your network. So it's between servers and servers, or to your PC. Two printers. It shares resources. Usually, some differences in protocols. It's a little more beefy. There's a little more to it. It requires more information about your network. It's in theory faster, better, faster, better, more secure. But again, it has to be set up as part of a network, typically. File sharing is it's not for file sharing. But if you're going out the internet, you're probably not going to do SMB. That's, like I said, within a network, a defined network. FTP is more like it's simpler. And also, I should need to make a point, FTP is for short-term connections. SMB is almost continuous in many cases. You might have servers talking to each other nonstop. It's trading like DNS stuff. Or if you have a secondary DHCP, then there might be a case for that. Packet tracer for FTP, yay! Take a look. Exploring, So pretty much the end of it, but there are a bunch of packet tracers to give you an opportunity to try some stuff out. It's up to you if you want to do it. Again, as everything else, you don't need to be an expert. I suggest you even try a little bit. Don't sweat it. Don't sweat it too much. Again, we talked about the most common application layer protocols and how they worked. Peer-to-peer, client-side, HTTP, SMT, IMAP, POP, DNS, DHCP, all these things. This is how these are application layers, but they're stuff that you as a networker would deal with, or you as an individual have to deal with from time to time. So this is it for Chapter 10. I will get to Chapter 11 as soon as I can.